Our next important topic is model creation. A mining model. It is created by applying an algorithm to the data. That means if we collect the data about the customer. Now this data has to be modeled properly. And for modeling the data, we require a particular algorithm. You create a data mining model by following certain general steps. What are those steps? The very first one. Here we are discussing that we want to create a model. We want to analyze the requirements, the needs of our customer. So for that building of that sort of model, what do we require? The very first step here that we need is create the underlying mining structure and include the columns of data that might be needed. So first of all, we have to create the mining structure. That means if we are talking about one certain product, what are columns related to the product can be? If we are talking about one product, we can talk about the brand of that product. We can talk about the packaging of that product. We can talk about the color of that product. We can talk about the price of that product. What all columns do we need related to that product? So first of all, we need to create that sort of mining structure. Then we have to select the algorithm that is best suited to this analytical task. If you're talking about the customers, so which algorithm should be used here? Which algorithm will suit best to the analytical task? That has to be analyzed because we have number of algorithms. We have the classification algorithm, we have the clustering algorithm, we have the regression algorithm. Number of algorithms are there. So we need to select the correct algorithm which is best suited to our particular analytical task. Now the third step, choose the column from the structure to use in the model. We have to choose the column and specify how they should be used, which column contains the outcome you want to predict and which column are for the input only and so forth. That means you have to choose the columns from the structure to use in the model. What all columns are required for that model? For a particular product, we have number of columns. Do we need all the columns? Which all columns are required? Which will produce the outcome for ourselves? Which columns are just for the input sake? Which are required for the output? Which are required for the result? So we have to choose the columns if we want to create the model. After that, optionally we can set the parameters to fine-tune the processing by the algorithm. We need to set certain parameters. Those parameters will be required to be set to fine-tune the processing of the algorithm. If you want that our algorithm, it should process in a proper way. We need to set certain parameters for that. And this is an optional thing. So this is the next step that we can perform. After that, populate the model with data by processing the structure and the model. We have to populate the model with data. That means once it is being done, now we have to provide all the data to our model by processing the structure and the model. So these are the basic steps which are required for the creation of model for our data mining task. Now, talking about selecting the data mining algorithm. Since we have seen that in our model creation, when we talk about the model creation, we require to choose the algorithm. So how to select the correct data mining algorithm? This is a question. An algorithm in data mining, it is a set of heuristics and calculation that creates a model from the data. The step-by-step process, the set of all the heuristics and the calculation which will create the model from the data, that is known as the algorithm. To create a model, the algorithm, it first analyzes the data that you provide, looking for specific type of patterns or trends. That means whatever data you provide, we need to find the patterns between the data. We need to find the relationship or the trends between the data. Like we have talked about a customer, if we say that he buys a product for regularly for 5 months. So we have identified the pattern in his buying habit that this particular customer buys this product. That is a sort of pattern that we can use, that we can identify. Now, the algorithm, it uses the result of this analysis over many iterations to find the optimal parameters for creating the mining model. So, using this, we need to find the optimal parameters for creating the mining model. These parameters, they are then applied across the entire data set to extract the actionable pattern and detailed statistics. So, once we have selected the parameters, the optimal parameters, these parameters, they are to be applied across the entire data set to extract the actionable patterns and the detailed statistics. Now, once all these steps are done, we have to choose the best algorithm to use for a specific analytical task, and it can be a challenge because there are a number of algorithms. We have to analyze that which algorithm will work best for this particular sort of data mining. We have to analyze this. So, choosing the best algorithm to be used for a specific analytical task, because every business is different. All the processes that take place in various businesses, they are quite different. So, depending on our specific analytical task, for what reason are we creating this model? For what reason are we using these data mining techniques? So, for analyzing that, we need to choose the best algorithm for the specific analytical task. And this can be a challenge for the users. While you can use different algorithms to perform the same business task, each algorithm, it produces a different result. And some algorithms, they can produce more than one type of result. Depending on the kind of data, depending on the requirements of the customer, what happens sometimes when you choose different algorithm to perform the same task? If you're using different algorithm, each algorithm, it will produce a different result. So now you have to choose that what result matches with the requirement of the business. Which result will produce us the maximum output, that has to be analyzed. And that is why selecting the data mining algorithm, it is a big task in itself. And some algorithm, they can produce more than one type of result too. So that is why the analysis and the selection of data mining algorithm, it is a big challenge in itself. So, we basically categorize our algorithms into 5 categories. First is the classification algorithm. Second is the regression algorithms. Third is segmentation algorithm. Fourth one, association algorithm. And the fifth is sequence analysis algorithms. Now, these algorithms, they all perform different functions. So, let us discuss one by one all of them. Like the first one, which is a classification algorithm. Classification means divide into different groups. Like the characteristic of any object. You just have to classify it into different groups. Like if you have been given various balls of different color. Red color, yellow color, blue color. So you just have to pick up red balls and keep them together. Yellow balls together and blue balls together. So this is classifying. That means to predict one or more discrete variables based on the other attributes in the data set. Like red color is different from yellow, so it will be kept separately. Red separate, yellow separate, blue separate. So that means we are classifying the various variables into different categories whose characteristic we already know. We just have to keep them into different groups. So that is classification algorithm that we use in data mining. Like if we have data, lot of data available. So according to the characteristic, we can use an algorithm which can classify the data into different groups. So that is one which is known as the classification algorithm. Talking about the second algorithm, which is most frequently used in our data mining techniques, that is the regression algorithm. Regression, it predicts one or more continuous numeric variable like profit or loss based on other attributes in the dataset. If you talk about regression algorithm, that means you already know one variable on the basis of which you can take out the second variable. Like if we talk about the profit or loss of a company, if you know the total and you know the profit obtained, so you can definitely reach to the loss that the company has gone into. The variable, one variable is known, and depending on that, other variable can be found out. So in those cases, we use a regression algorithm. Another example of regression algorithm, it can be like if you know one known variable, other value you can find out. If you know the demand which is going to be produced in an organization for any product, so you can automatically, depending on the demand, increase the sale or decrease the sale. So demand is known, then you can increase or decrease your supply according to that. So depending on the demand, which is an independent variable, and depending on this independent variable, you can increase or decrease the supply. So that means supply is here dependent on the demand. So in those cases, that is an example of regression algorithm, where the value of one is known, which is an independent variable, and on the basis of which another value can be found out. So that is an example of regression algorithm in data mining. Talking about the third algorithm, which is a segmentation algorithm. Segmentation, it divides the data into group or clusters of items that have similar properties. Here in segmentation algorithm, whatever data we achieve, we do not know what that data is for. How can it be used? But depending on the similar characteristic, we cluster the data into different groups. That means we are segmenting our data. We have a whole database from where we are retrieving the data, and whatever data receiving, we just cluster them into different categories depending on their distinguishing between each other. Depending on how they distinguish between each other, we segment them into different cluster. So that is segmentation algorithm. Talking about the next one, which is the association algorithm. Association algorithm, it finds the correlation between different attributes in our data set, how they are associated with each other. Finding the correlation between different attributes in a data set. We can take an example like if you purchase a product online, what are the chances that you buy some similar product or something related to that product? Like if you buy a dress, what are the chances that you buy same colored shoes with it? So that is association algorithm. We are associating one thing with another thing, finding the correlation between different attributes in a data set. So that is what an association algorithm is. Talking about the fifth one, which is a sequence analysis algorithm. Sequence analysis algorithm, it will summarize the sequences or episodes in data. What do we mean by frequent sequences? Like a series of clicks on a website. That is an example of sequence analysis algorithm. Or a series of log events preceding the machine maintenance. That means some events which occur in series. So that is what is sequence analysis algorithm used for. Like if you click on a website, you click on one link, then you click on another link, then another one. In sequence, what all activities you are doing. So in that case, we can use the sequence analysis algorithm. So basically, these 5 algorithms, if we have a lot of data in our data warehouse and we are retrieving that data, so is it possible to analyze each and every part of data and work on it? No. What do we do first? We apply any of these algorithms, whichever suits us. And depending on this algorithm, if we cluster some of the data together, so then the operation on that data can be done together. Similarly, if we obtain the result of 1 and depending on that, we can obtain the result for the next variable. So that becomes easier for us. So that is why in data mining, it is very important to use algorithms, because they help us lot in making our task of data mining easier. So that is why we have to use these algorithms for the data mining. Now, the mining model that an algorithm creates from your data, it can take various forms, including like a set of clusters that describe how the cases in a data set are related. If you have a cluster of data, then you can perform similar operation on that cluster of data. So, like if what you can do, if you are doing online shopping, you in the search box you type something, like you type dresses for party. So what will happen? All the dresses related to party, they will start appearing. So how are they dealt with? They are kept in a cluster together, that when this kind of search sequence will occur, all these dresses will be displayed together. So we do not have to every time go and look for the dress, and if it satisfies our search criteria, we will retrieve it. No, we have already formed a cluster of those dresses together into the party wear dresses. So whenever this kind of search query will occur, it will retrieve all those dresses. So dresses here, it is serving as a data. Now this data will be retrieved when it matches our search criteria. So that is why these algorithms are how they are used. So a set of clusters that describe how the cases in our data sets are related, they can be used. Next, a decision tree which predicts an outcome and describe how different criteria affect that outcome. That means a decision tree. If you take this, then next will be this, next will be this. A whole decision tree, it will predict the outcome, beginning from the root to the bottom. So, a decision tree which can predict an outcome and describe how different criteria affect that outcome. So, that kind of decision tree can be built using these different algorithms. Then, a mathematical model that forecasts the sale. Using these algorithms, we can build a mathematical model which will forecast the sale. How will this forecasting be done? Like if we buy some product, what are the chances? Can we forecast? Can we predict that in this, if a person is buying this party wear dress, what are the chances he is going to buy some sandals related to it? That is forecasting the sale. So for that, a mathematical model can be built. So that is what we can do in data mining. Then a set of rules which describe how the products are grouped together in a transaction and the probabilities that products are purchased together. See, if you go to a grocery store and you buy bread, what are the chances you will buy butter with it? What are the chances you can buy jam with it? So what if in a store, on one side, on one shelf, bread is available. In the adjacent shelf itself, they have kept butter or jam or something else which can be related to bread, like chocolate spread or something like that. So there are chances that if a person will buy bread, he will associate, he will group his purchase of the next item which is there in the shelf. So that is how it happens. A set of rules which describe how the products are grouped together in a transaction and the probability that these products are purchased together. If this kind of format is followed, so those increase the chances of sale of those products. If we keep the related products together, so the chances of customer buying those related products together will increase. Depending on one product, another one will be automatically purchased. So that is how it happens in data mining too. In our database, if we have the data, so we will group the data which is required together into one cluster or into one group. So that is how we do in data mining. Some algorithm, they can produce more than one type of result. For example, like we have just seen these 5 algorithms. They are all performing their own set of functions. But some algorithm, they can produce more than one type of result. How? For example, you can use the decision tree algorithm not only for prediction, but also a way to reduce the number of columns in a data set. Because the decision tree, it can identify the columns that do not affect the final mining model. Like we have seen, the this decision tree algorithm, it is generally used for making the prediction. So, this particular algorithm, it can also be used to reduce the number of columns in a data set. Because the decision tree knows that depending on these columns of our table, this decision tree, the outcome of this decision tree is getting affected. And if there are more columns which are not required, which are not performing any function in the outcome, so decision tree, it will automatically reduce those columns. So that is how even one algorithm, it can be used to perform more than one type of result. There is no reason that you should be limited to one algorithm in your solution. Like experienced analysts, they will sometimes use one algorithm to determine the most effective input, that is the variable, and then apply a different algorithm to predict a specific outcome based on that data. So our data analysts who are working on so much of data, they are not restricted to use one algorithm for reaching to their outcome. They can use more than one algorithm together to produce a more effective outcome for it. So you should not be limited to one algorithm when you want to find the solution of your data set. You may sometimes use more than one algorithm to determine the most effective input, and you can then apply a different algorithm to predict a specific outcome based on that data. Like if, for an example, if we consider the SQL Server data mining, which is used most frequently, SQL Server data mining. This one, it lets you build multiple models on a single mining structure. So within a single mining solution, you could use a clustering algorithm, a decision tree model, and a naive Bayes model to get different views of your data. That means on single model, you can use different algorithms. In a single model, you can itself use a clustering algorithm along with decision tree model along with the naive Bayes model. Why are they being used? To get different views of the data. Using one algorithm, we can only predict one outcome. But if we use different algorithm in the same model of data set, so there are chances increases to get the different views of your data. That what if we do this? So that is why we can use more than one algorithm. You might also use multiple algorithms within a single solution to perform the separate task. Like example, you could use regression to obtain the financial forecast and use a neural network algorithm to perform the analysis of factors that will influence the forecast. How can you use multiple algorithms? So we can use regression. In regression, what we have seen, that we know the value of one, and depending on that value, we can predict the value of the next variable. So to obtain the forecast, we can use regression. And for the same thing, neural network algorithm can also be used. It will perform an analysis of factors that are influencing the forecast. So that is how we can use multiple algorithms together to obtain the effective results for the data mining techniques for the data sets that we are having. So that is a basic usage of your algorithm on the data mining.